Hi guys, welcome back to the channel. Today we will be diving into some applications of shell scripts. This is a continuation of the previous session where we dived into some basics regarding bash and shell scripting. We dived into some other aspects as well, which involved modifying the executable permissions for certain scripts which exist within your present working directory, and we also executed some of those scripts in different methodologies which are available within Linux. So yeah, this is a continuation of that, and yeah, we will pick up from where we left. This is my programming environment, and this is the present working directory, and within the directory you can see that there are two files, one folder to be more precise, and one shell script. Within the directory called dir, there are a bunch of shell scripts which are available. For the first program, we will basically try to modify or make a script which basically creates a backup of all the files which are there within the dir folder. So yeah, let's jump straight into it. So let me just clear my workspace, and yeah, so here within vi editor we can open up our backup.sh script, and you can already see that I have already written a script which compresses the files which are there within the folder dir, and basically compresses that file into backup.tar.gz. Here I have specified the relative path of my directory. So yeah, and here two things happen. First, the compression takes place, followed by the message which is displayed once the backup process has been successfully completed upon the execution of this specific folder. So yeah, let us write and quit. You can execute this as bash backup.sh, and once you hit enter, you would see the message appear onto the terminal, and here you can see that our files have been located. Each of those locations have been showcased, and these files have been successfully compressed and have been stored within this specific backup.tar.gz file that we had specified. So yeah, here we have effectively automated the process of backing up files. Now let us create a new file called system resource monitoring. So let's write something like system monitor. Let's write something like this, sys.sh, something like this. Go into insert mode. Let us import our shebang file, bash. Here we will basically write a simple script to check our disk usage. Within Linux there is a specifically easy command for this, which basically showcases the disk usage with the help of the df command, and this data would be showcased in a human readable format along with the disk space. This is pretty easy. We will save this, and yeah, let us just go with bash.sys.sh. Once you hit enter, you can see that we basically get the data associated with the amount of size which is available on our disk, the amount of size which is really available to use, and furthermore other details. So yeah, this basically has been showcased in a human readable format. However, if you just type df and hit enter, you would see something similar. However, this has not been tailored specifically for human readability in mind. So yeah, we can also write scripts to automate software installations. Let's say we would like to install certain packages with regards to, let's say, vim, curl and git. So for that we can write another script like vi followed by the name of our script, which we write install, let's say, installation.sh. And once we do that, we go into insert mode. We bring back our shebang file, the first line of your code, followed by the command sudo apt update and sudo apt install vim curl and git. So here what we have done is that we have effectively said that if there are pre-existing packages of vim, curl or git, we would like to update that, as well as if that file does not indeed exist, we will anyway go ahead and install the latest versions of the packages vim, curl and git onto our system. So here we have we basically update the system, and then we also install vim, curl, git in one go. So yeah, let's just save this script. Then we go ahead and write bash installation.sh. Once you hit enter, please note that this password that you enter should be your own, and you should know this password. And yeah, this password is basically the same one that you set up at the very initial phases of installing any distribution or distro of Linux. So yeah, we will basically wait as it goes ahead and gets the information. Yeah, I'm back. The installation has been done successfully. In order to check your the status of these specific packages which have been installed, you basically write curl -- version in order to check your version number for the latest curl which has been installed onto your system. So here you can see that I have successfully installed this pre-existing file, and you can also see the latest release date for the same. We can do the same for git and vim as well. So you can see that in both cases I have successfully installed the latest versions of git and vim as well. So yeah, this script has successfully updated our system, and we have also installed vim, curl and git in one go. So yeah, so to summarize, we have basically written a shell script. With the help of the shebang file, we have basically introduced the bash interpreter into our file. We basically modified our script. We basically ran the script with bash, and we have successfully demonstrated the process of automating software installation, monitoring system resources, as well as automated backups. Now we will now move on to another aspect with regards to shell scripting, where concepts like loops, conditions and functions are gonna play a huge role. It is essential that we know how to use these along with our automation tasks to perform our processes much more easier. So yeah, the first conditional statement would be in bash that we will discuss would be if and else. So yeah, we basically open up our terminal into our main present working directory. Just a minute, a little bit less. Let's create a new directory called conditions. So we basically move into that particular file, clear the workspace. Here we will basically create a VI script called, let's say, condition1.sh. Yeah, here we will now again always import your interpreter into your script. For this demonstration of if-else statement, we will basically take a number from the user and basically determine if this specific number which the user has defined, if it is greater than 10, less than 10, or if it is exactly equal to 10. So here we will write something like echo please enter a number. Then we will take our value into the num variable. We will set up our condition statement within square brackets, and we will take our number and check if it is greater than 10. If this condition is satisfied, then we will basically print out the message, the number is greater than 10. Something like this. We will now define an elif statement along the similar structure, where we write num if it is equal to 10, then we will print out the echo command, the number is exactly 10, else we will just print out that the number is less than 10. We will close this condition. Another way that you could do this is to actually set up another condition. Let's say if the input from the user is a string, and in that scenario we would basically get the else statement getting printed, which is not a good way to do it. So there are certain test cases that you can implement. So for this I would anyway implement the number is less than 10. I will implement this. Otherwise we will just print out the message, this input is not a number, or let's just say this input is invalid. Let's just give out the num name as well. Let's just give it the num here itself. So yeah, so here we are basically evaluating the conditions with respect to whether this number from the user is greater than 10, equal to 10, or less than 10. Otherwise, if none of the conditions are met, then we can safely say that the number which the user has given is probably an invalid input. Followed by, we will close the condition with fi, and we will write quit. So yeah, so here we have basically created a script which follows up with a basic if else statement, whereby which to again explore our structure, we can just go back up and see here the first part would basically prompt the user to insert a number. The read command basically takes that input from the user, while the first conditional statement basically checks if the number is greater than 10. The second condition basically checks if the number is basically equal to 10. The third condition basically checks if that specific number is less than 10. And based on these conditions, if the statements are satisfied, these particular echo commands with respect to each of them will get executed. So yeah, let's just try to execute this. Let's just write bash. Let's just clear our workspace first, and let's say bash followed by condition1.sh. Here let's say we will give it 15. Once you hit enter, you can see that our number was correctly deduced to be greater than 10. So yeah, this is pretty simple, but let's try to go up with something a little bit more complex. So for this complex program, let's complex script or a complex implementation of this if else condition, we can basically go ahead with the idea of basically sending the user a warning based on whether the disk usage is critically high or if it is within a range. For that, we would basically be modifying or taking input from an output of another command. So yeah, let's try that. So if you are not already aware, when you use df hyphen and hit enter / you basically get the information related to your disk usage, but here we need to get hold of the correct information which shows you that specific uh, data that we are looking for. So here you can see two rows. First, with basically we having around about, let's say, yeah, let's say 5 columns. So yeah, here the file system is like this is the structure, as you can see, and here we want to get hold of this specific data. Here under use percentage we want to get hold of 40%. So to do that, we basically need to write this specific command, df-/. From here we basically take this output and we would pass it to awk, and here awk would basically, yeah, let me just rewrite that. We would basically extract the second row, and from here once I hit enter, you can see that we basically have now taken up the second row from our df// command. But here we are still not close to our answer. We need to get hold of this specific number. So for that we again write the same command as before and then write print $5. Here what we have done is we are extracting the fifth element from this entire output, and if I hit enter, you can see that I have gotten hold of the percent symbol as well. But here we do not need the percentage as well, so for that we only need to get hold of the number. So we will again pass this output into the stream editor, where we will substitute the percent symbol with an empty character. So here there wouldn't be anything. Once I hit enter, you can see that we have gotten hold of our number. So based on this, we basically know that this is the server disk space which is being used, and therefore using this we can use implement a script which automatically sends the user messages warning or cautioning about the usage disk. So yeah, let's just write that something like this. Let's implement the bin bash, yeah, and then we will basically define the same command structure as before, and yeah, let's just specify our data. So here we would basically mention df, and then this output basically we send it to awk, which basically has nr2, which will extract the second row. We pass that, and from here we would basically take the fifth element, which is of our interest, which is %40. Since we also need to get rid of the percent symbol which is there, we need to send it to stream editor, which would substitute the percent symbol with an empty character. Then we will close this. So yeah, here we have successfully taken up, yeah, wait a minute, I need to check this. Yeah, so we have successfully extracted the data and passed it into the disk_usage variable, and here then we will set up our structure. So here we will write if disk_usage is greater than or equal to 90, let's say something like this, then we will basically print out the message to the user that warning, disk usage $disk usage is critically high. Yeah, from here we can also define another condition which basically checks, basically we will basically set a range here. Since we are only cautioning the user, we will have to set it something like if the disk usage is less than 90 and if the disk usage is greater than 70, then we will basically send a message saying that yeah, we have to warn the user, like we are cautioning the user. So for that we basically set up an AND condition. So we write disk_usage, and yeah, we will basically write is less than 90 and disk usage is greater than or equal to 70. So we will just set that up 70, something like this. Yeah, so because of this we will basically send the usage a caution disk usage disk usage is, let's say, unusually high or something. Else we will just simply print echo disk usage is normal. We will print out our value and score usage. So yeah, and then we will close this, and yeah, so pretty much that wraps up our script. So yeah, once you hit this specific script in the form of bash server disk.sh and hit enter, you would basically see our output as the disk usage is normal. I hope you didn't get any other message, otherwise you have to go back and check your system specs. So yeah, another important aspects that I would like to talk about the script is that whenever you write conditional statements, always leave out certain spaces between the square braces as well as your condition. Moreover, same goes for the process of assigning the variable to this complex structure over here. So yeah, it's always a good practice to follow those methods. Yeah, so yeah, let's just now move on to our next script, which is loop. Well, now let's just try to clear our workspace. Yeah, for loops we will basically define something like loop. Let's say loop.sh, and here in this simple for loop implementation we will basically print numbers spanning from 1 to 5. Let's go into insert mode. We will basically implement bin / bash. Here we will basically write for I in and the numbers 1 to 5. For them we will do this specific operation where we basically print number and we write for I. Okay, just need to close this. From here we basically try done at the end, and then we hit this, and then we write hash loop.sh, and yeah, as expected this loop would basically print the numbers spanning from 1 to 5. Another way to do this same process is to basically loop through the files in a directory. Let's say we will modify the same script above and we would try to let's say loop through the files which are there within directory dir folder. So yeah, let's just try to do that. So here we will write a new script called, let's write loop files sh. Go to insert mode. Into insert mode we basically write our script. So yeah, for this we will write, let's say, file in. Let's just give the relative path to our directory, and here we are gonna basically do this for all the files which end with .sh, and for this we basically write do, and let's just say processing or something, processing file. Let's just say file, and let's just give out file, and here we will just close it. And yeah, so what we expect to do here is to basically print out the names of all the files which end up with the extension .sh, and all those names will be printed out along with this echo statement. So let's just try to do that. So yeah, you can see that we have successfully looped through the files which are there within the dir folder, and all the script files which end with .sh have been printed. We can try to do the same, let's say with the help of while loop. For that, we will basically go back into our conditions.sh, and we will just create a while loop.sh file. Sh file, yeah. We import our bin and bash, and here we basically set up counter to 5. The difference between the while and the for loop is that while loop will perform the loop as long as the condition remains true. However, for loop, the looping will only take place as long as we have set a range. So yeah, here the value is 5, and here we will basically write let's say while. We'll basically write something like this: while, let's say, the count is greater 0, we will perform the task of, let's say, counting down. So here we will try to decrease the value of count after each iteration, and once that happens, we will basically see countdown happening from 5 to 1. So yeah, so here we basically will be decreasing the value of count every time we complete an iteration. So let's just do that. So we will do something like this, and we will end the script. Let's try to do this, and let's just write bash while.sh. Okay, always remember that whenever you set up your scripts, you should always set up some space before and after your condition between the square braces, otherwise you will get an error like this, which states that it is the trailing square brace is missing, but that's not the case. We do have it, but because of the lack of that space, it's not recognized. So yeah, since we did that correction, our script is working, and as I have already mentioned, the countdown basically takes place from 5 to 1. Let's try to do something different. So let's just say we would like to make a script which would check the CPU usage every 5 seconds, and it would exit if the usage is below 50. So for that, we basically need to go back to another important command structure, which basically talks about the usage. For example, if you type top into your let's just clear our workspace. If you type top and hit enter, you would see all this data with regards to your CPU usage in real time. So we would like to take some of that data from here, but yeah, here this is too much of information, and it's happening in real time. So if you press Ctrl C once, it will basically quit. So for that, we basically type top -b, and once you do that, you basically get the data in a little bit more formatted CSV-ish way. But here we would like to extract the first let's say the first column. Just try to do that. Let's just go to the very bottom of our script. Okay, this is too much data which all at once. Okay, it's still going, so we'll just quit. So we will write something like this -b and 1. Once you hit that, you would see the data being shown as a snapshot. So here we basically write top -b and 1 in order to get a snapshot of your disk usage. but yeah, this is too much of data and we would not want to get all of it, so let's just try to only get hold of the data which is relevant to the CPU. So here we will write something like this and hit enter. So you can see that the data basically shows you the first row. So here what has happened is that this specific command would go ahead and extract the column values of person CPU, and all that data is basically shown as such. But here we don't want to use all of it. What we would like to get hold of is the second element from this entire structure. So here we will again pass this through awk, and we will basically grab that from with the help of print. So like 2, hit enter. So yeah, we have basically gotten hold of the second column, second element from this entire list. But yeah, since this is happening in real time, you will always be getting some arbitrary numbers which keep on changing because it's not always gonna be the same. So yeah, that's the idea. So we can basically try to let's say create a script like that. We will clear our structure over here, and let's just say we will write CPU usage. Let's just write CPU underscore usage dot sh. Okay, let me go back and change the name. It's just rm-r CPU usage. Yeah, let's just create a new file. It's just a CPU. I know it's a bit hard to read it, but yeah, this is how it would be. So yeah, we will go into insert mode. We will try to yeah, here we will basically set up the while loop to be true, and as long as this value remains true, this will constantly keep this process of checking the usage statistics always. So we will do something like this. Let's just top -b-n1. We basically pass that to grep, which could only get hold of the CPU. Let's just say something like this, and from here we basically pass it to awk, which would get hold of that specific element that we want, which is element 2, which we would print out as CPU usage, and write the value here in the form of %. So yeah, since we are printing this value out, we can also check this statement against, let's say if it is less than 50%, then it is normal. So if, let's say, the value of this echo statement is, let's just say $usage is less than 50, here we would also need to pass this information into a basic calculator. The bc-l is basically used here. So here we basically would write something like this, -l. Let me just go to my structure here, -l. So here the option BC basically stands for basic calculator. It's a command line utility to perform the arithmetic operation to evaluate mathematical expressions. So here we basically use this from the math library. So the -l option, which is part of BC, basically would check, it would really load this this library, and it would allow us to increase this precision of the calculation. So here we would get a much more accurate result. Let's just try to execute this, and let's just say then if this condition is valid, then yeah, one more thing that I got is to close this. something like this. I'm getting a strange error here, but let me try to change this. Okay, let me just try to break this. I suppose I need to end it with a break statement. So like, let's just give a message if the usage is normal now. So yeah, and we need to break the loop if this statement is correct, else we will just send it to sleep. Let's say it will check every 5 seconds, and yeah, we will just basically close this with the help of done. One more thing I might be forgetting is to just try this. It's a bit strange, I'm getting this highlighted as red, which is just let me try to okay, let me just see what the issue is. Let me just write quit ls, we'll write bash cpu usage at sh. Okay, in line 8 there is some issue. We'll quit and exit our, we'll just go back to cpu usage sh. Here we had an issue on line number 8, which is this line, which is a bit strange. Let me just try to make some modifications sometimes. Okay, let me try that again, maybe this time it will work. Okay, this does work, but for some reason at line number 8, yeah, it is working. Okay, so yeah, this script will keep running. I don't know what that issue was, but yeah, here this process will keep happening as long as we do not cross the threshold of 50. So yeah, we are getting some real-time updates with regards to our CPU usage. Yeah, so that's interesting. So we can quit out of this by pressing Ctrl C, and we have basically stopped the script from working. Another use of scripts with regards to some higher form of shell scripting would be to use functions. Functions allow us to basically reuse codes while we use script. Let's just write a simple function like function.sh, and yeah, let's go to insert mode. We'll just write something like bin. Let's just write bash. Here we would basically write greet underscore user. Let's just set this up. We'll just mention echo hello, and we will take a parameter which accepts the argument which is being passed, and we will set up greet user, okay, greet underscore user, followed by the name. Let's just set this to Alice or something, or yeah, so we can just quit. And yeah, once I hit bash function.sh, you can see that we basically passed the argument which is a name Alice, which was accepted by $1 parameter, and this $1 parameter would basically print out this specific information that we just passed, which is the name Alice, as an echo statement. So yeah, this is pretty easy, but let's just try to make a script which would automatically back up let's say the files into a zip file or a tar file whenever we call this function. So let's just try that. So here we can use this structure for the sake of, let's say, making a backup file of this specific conditions. Here in conditions you can see we have several of these scripts, and we can just try to make a script for that. Let's just try that. So let's just say backup, let's say backups.sh. we go into insert mode, bash, And yeah, here we basically would set up a function called backup file, and let's just say something like this. Here we would need to specify the source, so we will like say source, and let's say here source, and here we would set up let's say the source to be the file here, which would be conditions. So let's just write conditions. We are just giving an absolute path here because it's much easier to do that. Followed by the backup. So here we will basically write conditions again, followed by an underscore. Let's just try to add the date for this, the date when this backup is being made as a date command. Let's just try to get hold of let's say let's just try to get hold of the first one. Let's just write %f, followed by .gz, and then we will basically compress. Let's just write backup complete. Okay, let's just write back. Let's just write up, followed by the source, and then we will just print out the message backup is successful, followed by the name of the backup file. Let's just write back. So yeah, and then we will have to invoke this particular function. Yeah, so let's just try to execute this. We might get some error depending on if there is if we are working with a relative or absolute paths. Okay, let's just see. Yeah, so yeah, here it has worked out, but yeah, I haven't gotten the date function to work properly. So yeah, so this script will basically go ahead and create a backup for your conditions file folder and all the files which are there. So yeah, this allows it to reuse the script multiple times, and yeah, this is a pretty good way of working with this form of scripts. There are more to this. We can also set up a combined version of all of these files scripts together, which basically would check the CPU usage, the disk usage, as well as the memory, and it would basically perform all of these steps at once. So yeah, this is the way we basically write or combine multiple scripts, which we will delve into the next session. So yeah, this much is for today, and I hope you learned something, and I will meet you in the next one. Bye.